Hello guys, welcome to the next class. In this class, we'll discuss the key and solution of the modulus assignment, which I have given you in the last class. So let us start with the first problem. The first problem answer is close 0 to close 1 by 4 union close 3 by 4 to 1. Okay, I hope all of you would have got this thing. So it's 2x minus 1 mod belongs to close 1 to close 1. You can say using the property, fourth property, that 2x minus 1 will belong to minus 1 to minus half union half to 1. Then you will add 1 to both sides, add 1 to each term, then you divide by 2. Finally, you end up with this thing. Close 0 to close 1 by 4 union 3 by 4 to 1. Everything closed. Next problem. Answer for the next problem is minus 8 and 12. Those who couldn't solve, see this guys. This mod x minus 2 minus 3 will be plus minus 7. So first case plus 7, second case minus 7. So the first case you get mod x minus 2 equal to 10. So x minus 2 will be plus minus 10, which gives you minus 8 and 12. Second case you get x minus 2 mod equal to minus 4, which is not possible. So we don't get anything from the second case. Next problem. The answer for third problem is close close minus 3 to close 1 union close 3 to 7. So how do we get this thing? Again, we use the second property. We get mod x minus 3 belongs to minus 2 to 2. Add 3 both sides. So mod x minus 2 1 to 5. Using the fourth property, x minus 2 belong to minus 5 to minus 1 union 1 to 5. Add 2 to each term, you get minus 3 to 1 union 3 to 7. Next problem. For the fourth problem, the final answer is x belongs to 0 to 8 union minus infinity to minus 2 close union close 10 to infinity. So this or this. See, how do we get this thing? So using the third property, we can say mod x minus 4 minus 5 belongs to minus infinity to minus 1 close union 1 close to infinity. So taking the first case, in first case we get this thing. First case basically when the left side lie in this range. So minus infinity to minus 1 means less than equal to minus 1. So x minus 4 mod less than equal to 4. When you solve, you get x minus 4 using second property minus 4 to 4. Add 4, you get x belongs to 0 to 8. In the second case, 1 to infinity means greater than equal to 1. So x minus 4 mod greater than equal to 6. So x minus 4 belong to, using the third property, minus infinity to minus 6 union 6 to infinity. Add 4 to each term, you get minus infinity to minus 2 union 10 to infinity. I hope it makes sense, all of you. Next one. For the fifth problem, the final answer is open minus 2 open minus 2 to minus 1 close union 1 close to open 2. How do we get this thing? We have this thing greater than equal to 1, and like we discussed in the VV curve method class, do not cross multiply. Okay, if you haven't seen, you can go back and check that class. Now, bring everything to one side, you get 1 plus 1 over mod x minus 2 less than equal to 0. Take LCM, you get mod x minus 2 plus 1 by mod x minus 2 less than equal to 0. So you get mod x minus 1 by mod x minus 2 less than equal to 0. Use wavy curve here. 1 and 2 are the roots. Okay, we're using wavy curve on mod x. So whatever range we'll get here, there'll be the range of mod x. Okay, so roots of mod x right now are 1 and 2. So positive, negative, positive. And you want less than equal to 0. So mod x belongs to closed 1 to open 2. Using the fourth property, minus 2 to minus 1, union 1 to 2. So 1 and minus are closed, 2 and minus 2 are open because 2 was the root of denominator. I hope it makes sense. Next problem. Now next is an interesting problem. See, here we use the last two properties, not last two, I think fifth and seventh property. What we discussed there? See, x minus 2 mod plus 2x minus 3 mod equal to mod x minus 1. X minus 2 mod we can write as 2 minus x mod also, because we discussed the property minus x mod is equal to mod x. So if I write as 2 minus x, still mod will be same. Now mod x 2 minus x plus 2x minus 3 mod equal to x minus 1. Now why we writing this thing? In the next step you will see we can write x minus 1 as this plus this. 2 minus x plus 2x minus 3 is x minus 1. So you can say mod x plus mod y is equal to mod x plus y. So when mod x plus mod y is equal to mod x plus y, we can say x into y is greater than equal to 0. So we get 2 minus x into 2x minus 3 greater than equal to 0. Again, we can just use the Wavy-Curve method. We get x minus 2, 2x minus 3 less than equal to 0. Use Wavy-Curve. Roots are 2 and 3 by 2. Plus minus plus. You want negative. So x belongs to 3 by 2 to 2, both closed. So I hope it is clear, guys. Important problem. Next, seventh one. 1 minus square root of x square minus 6x plus 9 greater than equal to 0. So 1 greater than equal to square root of x square minus 6x plus 9. You see, this thing is nothing but x minus 3 whole square. And when we cancel square and root, there will be a mod here. So we get 1 greater than equal to mod x minus 3. So if x minus 3 mod, we can say is less than equal to 1. So x minus 3 will be minus 1 to 1. So x will be 2 to 4. The final answer here is 2 to 4. Next. For the eighth problem, answer is minus 1. If we haven't got this correct, see guys. We have mod x square minus 1 plus x plus 1 equal to 0. So x square minus 1 we can write as x plus 1 into x minus 1. If you use wavy curve, we get plus minus plus on the roots minus 1 and 1. Why we're doing wavy curve here? Because we know mod we open only when we know if it is positive or negative. So we need to see when this thing is positive and this thing is negative. Now where do we see it positive? It is positive when it is more than 1 or less than minus 1. Basically greater than equal to 0 I'm taking. So x belongs to open minus infinity to minus 1 close union 1 to infinity. In this case, mod opens with positive sign. So x square minus 1 will be x square minus 1 plus x plus 1 equal to 0. You will see x plus 1 will be common from these two. We can use a square minus b square property here now. So x plus 1 is common. You get x minus 1 plus 1 equal to 0, which will be x plus 1 into x equal to 0. So roots are minus 1 and 0. You see, these roots must be in this interval only. Minus 1 is there, but 0 is not there. So only one solution we get from here. Second, when x belongs to minus 1 to 1, mod open with negative sign, we get this will become minus of x square minus 1 plus x plus 1 equal to 0. Again, x plus 1 will be common. From here, you will get minus 1, sorry, 1 minus x plus 1 equal to 0. When you simplify, you get x plus 1, 2 minus x equal to 0. Roots are minus 1 and 2. Both are not in this interval. So final answer is minus 1 only. Next problem. So the answer for this problem is no solution. See how. Here we have mod x square minus 3x plus 2 plus 3x plus 2 equal to 0. So first of all, we see x square minus 3x plus 2 when it is positive, when it is negative. You can see it is positive. Using wavy curve, we can find that out. The roots will be 1 and 2. So it will be positive in minus infinity to 1 union 2 to infinity. Now, so in this interval, we can say the mod will open with positive sign. So we get x square minus 3x plus 2 mod will become this x square minus 3x plus 2 plus 3x plus 2 equal to 0. So 3x cancel, you get x square plus 4 equal to 0. There is no solution. Next case, when will this thing be negative? It will be negative between 1 and 2. Again, using Viveka, we can find out. So between 1 and 2, the mod open with negative sign, you get minus x square plus 3x minus 2 plus 3x plus 2 equal to 0. So 2 and 2 cancel, you get x square minus 6x equal to 0, which give you 0 and 6. None of them lie in this range. Okay, in the second case, whatever solution you get, that should be from this interval only. But they do not lie in that interval, so answer will be just no solution. I hope it is clear, guys. Next. Now, this is a very interesting problem. See, what do we have here? We have 1 by square root of x plus 2 square root x minus 1 plus 1 by square root of x minus 2 square root x minus 1 is equal to 4. X belongs to 1 to 2. What do we see here, first of all? If you see this term, x plus 2 square root x minus 1, I add and subtract 1 here. We get x minus 1 plus 2 square root x minus 1 plus 1. This you can write as square root x minus 1 whole square plus 2 square root x minus 1 plus 1 square, which will be nothing but a square plus 2ab plus b square. So it will be a plus b whole square. So root x minus 1 plus 1 whole square. Next, x minus 2 square root x minus 1. Do the same thing over this. It will come out to be square root x minus 1 whole square. So we get what? So in the place of this thing, it will be root x minus 1 plus 1 whole square. In the place of this thing, it will be square root x minus 1 whole square. And there is a one more square root on that. So it's square root of root x minus 1 plus 1 whole square plus 1 by square root of root x minus 1 whole square. And you cancel this square and root, you get mod here. So it will be 1 by mod root x minus 1 plus 1 plus 1 by mod root x minus 1 equal to 4. Now, x belongs to 1 to 2. So you see this, now we have to see the thing inside mod, if it is positive or negative, because that will matter here. You see this first one, it's square root x minus 1 plus 1. We discussed square root always gives you positive value plus 1. So sum of these two will always be positive. So first mod we can directly say will be opened with positive sign. The second mod, however, we have x from 1 to 2. So x minus 1 will lie from 0 to 1. And square root of x minus 1 will also lie from 0 to 1. You can see, if number is from 0 to 1, the square root of 0 will be 0, square root of 1 will be 1. So lie between 0 and 1 only. So if I subtract 1 from here, it will lie between minus 1 and 0. So thing inside this mod is negative. So this mod will open with negative sign. So we get finally 1 by square root of x minus 1 plus 1 plus 1 by 1 minus square root of x minus 1 is equal to 4. So now just take LCM and simplify, you get the final answer to be 1.5. So this is a very good technique, guys, how we simplified these two things specifically. So do note this. It's a very good problem. Next one, guys. Okay, next we have 1 plus x whole square greater than equal to mod 1 minus x square. So 1 plus x square minus, we can take this thing this side, you get minus of, now 1 minus x square mod, you can write as x square minus 1 mod also, same thing, greater than equal to 0. X square minus 1 will be x plus 1 x minus 1. Now when will this be positive? When x is minus infinity to minus 1, you need 1 to infinity. In this scenario, the mod open with positive signs will just be same thing. So x plus 1 square minus x plus 1 into x minus 1 greater than or equal to 0. Now x plus 1 will be common here. You get x plus 1 minus x plus 1 will just be 2 times x plus 1 greater than or equal to 0. So x should be greater than or equal to minus 1. If you see the common, like if you see the values of x, like these values should be between this interval only. So the common values here are, you see, 1 to infinity union minus 1, because it says greater than or equal to minus 1. So from here you take only minus 1, here you can take everything. Next case, when x square minus 1 is less than 0, x belongs to minus 1 to 1. The mod open with negative signs, so this negative will become positive here. So x plus 1 square plus x plus 1 into x minus 1 greater than or equal to 0. X plus 1 will be common from these two. You get x plus 1 plus x minus 1. 1 and 1 cancel out. You get 2x into x plus 1 greater than or equal to 0. Okay, again you use the VV curve method on this. You get x belongs to minus infinity to minus 1, union 0 to infinity. Now we take common values here and here. It says minus 1 to 1 only. It says this thing. You can see nothing will be common here. From here we can have some values common, which will be 0 to 1. No? So x belongs to close 0 to open 1, common in this and this. So now x could be either this or this. And you combine these two, we get x belongs to close 0 to open infinity excluding, sorry, union minus 1. Because here we have 0 to infinity, sorry, here we have 0 to open 1, here we have close 1 to infinity. If you take a union over them, this is this or this. So if we take union over them, it will become just 0 to infinity. And minus 1, we have to add extra. I hope it is clear, guys. Next problem. Next we have mod x square minus 6x plus 8 is less than or equal to 4 minus x. So here just again factorize this. X square minus 6x plus 8 is x minus 2x minus 4. So when will this be greater than or equal to 0? When x belongs to minus infinity to 2 union 4 to infinity. Mod open with positive sign. We get x square minus 6x plus 8 plus x minus 4 less than or equal to 0. Just again factorize, take common, finally end up with this thing. Less than or equal to 0, x belongs to 1 to 4. Now take common values here and here. Will be common values here and here. See, 1 to 4. If I take common here, you get 1 to 2. So this and this common will be 1 to 2. This and this common will be just 4. Next scenario, when x square minus 6x plus 8 is less than 0, x belongs to 2 to 4. In that case, mod open with negative sign. So you get x square minus 6x plus 8. Basically, we get negative here, we take this side. So x square minus 6x plus 8 minus of this, you can write as minus of x minus 4 is greater than or equal to 0. Again, take common, simplify, you end up with x minus 4, x minus 3 greater than or equal to 0. So you get minus infinity to 3 closed, union 4 to infinity. I need to take common here. So this and this common, I think, will be 2 to 3. And here, nothing will be common because this is open 4. So finally, common in this and this will just be 2 to 3. Open 2 to close 3. Because here 3 is closed, I'll just open. And those brackets are open. So in the first scenario, we got this thing. Second, we got this thing. Now if we combine them like this or that, it will be close 1 to close 3 union 4. Next, 12th problem. 12th answer is 1 over square root 2 minus 1 plus 1 over square root 2 minus 1 minus 1 over square root 2. How we get this thing? We have x plus 1 mod x minus 1 equal to minus 1 by 2. Make two cases here, x greater than or equal to 0. Then mod x will be just x. Okay, it will be a quadratic equation. You get x square equal to 1 by 2. Roots will be plus minus 1 by root 2. It has to be greater than equal to 0. So we neglect this and take only this solution. Next, when x less than 0, mod x become minus x. You get x plus 1 minus x minus 1 equal to minus 1 by 2, which will be x plus 1 square equal to 1 by 2. So x plus 1 will be plus 1 by root 2 or minus 1 by root 2. So x will be minus 1 plus 1 by root 2 or minus 1 minus 1 by root 2. Both the values will be negative. So finally we get minus 1 plus 1 by root 2, minus 1 by root 2 and 1 by root 2 from the first case. I hope it is clear to all of you. Next problem. The answer for 13th is just minus 1 and 0. Same thing here, x greater than equal to 0, you get x plus x cube equal to 0. Take x common, 1 plus x square into x equal to 0, so x equal to 0 is the only solution. When x less than 0, the mod open with negative sign, you get x cube minus x. It's x cube minus x equal to 0, so x common, x square minus 1 into x equal to 0. So solutions will be 0 plus 1 minus 1. 0 and 1 we cannot take, only solution will be minus 1 from here. Because in this case x has to be less than 0. So final solution is just minus 1 and 0. Next, 14th problem. 14th problem again is based upon that mod x plus mod y equal to mod x plus y property. See what you can see here. We have x square minus 9 mod, which you can write as 9 minus x square mod. X square minus 4 mod as it is. 5 we can write as this plus this. So 9 minus x square plus x square minus 4. So mod x plus mod y equal to mod x plus y. So x into y greater than equal to 0. Take negative outside, you get x square minus 9, x square minus 4 less than equal to 0. Factorize them all, you get x plus 3, x minus 3, x plus 2, x minus 2 less than equal to 0. Use wavy curve, roots are minus 3, minus 2, 2 and 3, plus, minus, plus, minus, plus. You want negative, so minus 3 to minus 2, union 2 to 3. I hope it is clear, guys. Next, the last problem. This last problem was a bit lengthy, so we'll discuss in detail. We have mod x mod x minus 2 times mod x plus 1 plus 3 times mod x plus 2 is equal to 0. So this will solve here. So we have 3 mods here now. And we have to open the mod using the interval if the value is positive or negative. But there are 3 mods, so we'll have to take care of all of them. So what I'll do is I'll take root of each of them. So 0, minus 1, minus 2. 0, minus 1, minus 2. And I make 4 intervals on number line 1, 2, 3, 4. First interval less than minus 2. Second interval between minus 2 and minus 1. Third interval minus 1 and 0. Fourth interval is after 0. Now, in the first interval, when x is less than minus 2, you will see mod x. If x is less than minus 2, that means this x is negative, so mod x will open with a negative sign. You get minus 3x. Okay, and I have done one thing here. I'll send this to the right side. So we have mod x plus 3 mod x plus 2 equal to 2 mod x plus 1. This equation we will be solving. So in the first case, when x is less than minus 2, mod x become minus x. This case, here x less than minus 2, so this also will be negative. So this also will be minus 3x minus 6. This also will be negative, so it will become minus 2x minus 2. And this solve, you get x equal to minus 2, which does satisfy the boundary value here. You can check it separately. This will satisfy the equation. Next, between minus 2 and minus 1. So between minus 2 and minus 1, you will see this will be negative, this will be positive, this will be negative. So open accordingly. So minus x plus 3x plus 2 minus 2x minus 2. When you solve, you get x equal to minus 2. Again, already we have taken that. You can include here or here, same thing. Third case, when between minus 1 and 0, so this will still be negative, but this and this will be positive now. So you get minus x plus 3x plus 2 is equal to 2x plus 1. When you solve, you get x will get cancelled out everywhere. You just get 6 equal to 2, which is not correct. So there is no solution in the third case. Fourth case, when x is more than 0, so in this case, all of them will be positive. So everything will open with positive sign. You get x plus 3x plus 2 equal to 2x plus 1. When you solve, you get again x equal to minus 2, which we cannot take here, no? Because you are looking for the values of x which are greater than 0 or maybe equal to 0 also we can take, but not anything other than that. Less than 0 we cannot take. So there is no solution here also. So that means the only solution we get is minus 2. Okay, these are the solutions of all the 15 problems. If any problem is not clear, guys, you can just rewatch that. Otherwise, you can put a comment. I'll try to help you with that. Now, the bonus concept I told you, I'll give you. What is that? A special modulus function where we have sum of two modulus. See, mod x minus 2 plus mod x minus 4. What do we do here? I'll give you a very simple trick first of all, how to plot this graph quickly. Just see the points 2 and 4. So this is 0 at 2, this is 0 at 4. These are our critical points. Mark them on number line. Check the value of the function at 2. So basically find f of 2. When you put 2 here, this will become 0. This will be mod of minus 2, which will be 2. So you get value as 2. Okay, so value at 2 is 2. Now, value at 4 you have to find out. Now, when you put 4, you get this as 2, this as 0. So it will also be 2. Now, join these two. After that, there will be line going up like this. Below will be like, sorry, before will be going up like this. So you kind of have U-shaped graph. Earlier we had V shape, now it will be like U shape. That's all. So graph you can draw directly. Check value at 2, check value at 4, join them, and then after and before just draw two lines which are going up. Okay, graph we got, range also we get from there. So you can see the minimum value we got was 2 only, which was at 2 and 4, and all the points between. You can see after 4 and before 2 value is more than 2. So the minimum value of the function is 2. So range is close to infinity. Now, how do we get this thing? Now we'll discuss in detail. Shortcut is for you, and like shortcut is for the next time when you do this thing, you can just use the shortcut. But first time you need to understand also how do we get this thing. When x is more than 4, you can say this mod will open with positive sign. This will also open with positive sign. You get x minus 2 plus x minus 4 will become 2x minus 6. So it'll be a line. This line is basically y is equal to 2x minus 6. Next, when x is between 2 and 4, then this mod will open with positive sign, but this will open with negative sign. So you get x minus 2 minus x plus 4, which will x get cancelled out, you just get 2. That is why the value between 2 and 4 is a constant line. You can see this is always 2. Next, when x less than 2. For x less than 2, this will be negative, this will be negative. So both the mod open with negative sign. So you get minus x plus 2 minus x plus 4 will be 6 minus 2x will also be a line. So this line is y equal to 6 minus 2x. Okay, so between 2 and 4, y equal to 2, constant. After 4, y equal to 2x minus 6. Before 2, y equal to 6 minus 2x. Now, what are these pink lines and all? This is for the next part. We'll put these kind of questions. Find the number of solutions of fx equal to 5. What you will do here, you will draw a line y equal to 5 and see their point of intersection. At how many points does this line intersect our graph? You can see it will intersect at 2 points. One time this line, other time this line. So there are two solutions. Next, fx equal to 1. In fx equal to 1, you will draw a line y equal to 1. Now y equal to 1, you will see a line which will be like this. You know our range was 2 to infinity. So our graph does not intersect this line y equal to 1, so there will be no solution. Third, fx equal to 2. For fx equal to 2, you will draw a line which is y equal to 2. You will see between 2 and 4, they'll coincide. So we'll say between 2 and 4, every number is a solution here. So will be infinite solutions because talking about real numbers. So we'll say what are the solutions? X belongs 2 to 4. All the numbers here are solutions. Now in the first case, fx equal to 5, we got two solutions. But what if they ask those two solutions? What you have to do? You see there are 2 points of intersection. No? One is when it intersects this part, 6 minus 2x. Other is when it intersects 2x minus 6. Okay, in one case it intersects 6 minus 2x. In other, it intersects 2x minus 6. So just equate them. So one time equate 6 minus 2x with 5, we get x equal to 1 by 2. Other time equate 2x minus 6 with 5, we get x equal to 11 by 2. So the solutions are 1 by 2 and 11 by 2. So there are two solutions. Okay, so bottom line is next time you see this kind of function, just take those critical points 2 and 4, find the value at 2, find the value at 4, join them, get the graph between 2 and 4. After and before will be like line going up. So it will be a U-shaped graph. And if you need those lines, so on the right side, open both the mod with positive sign. On the left side, open both the mod with negative sign. So in this case, you got 2x minus 6 and 6 minus 2x. You will always select they'll be negative of each other. Okay, I hope it is clear, guys. That is all about modulus function. Next class, we'll start on logarithm, log, which is a very, very important concept. Okay, guys, bye everyone.